Today. Today's aim is we're going to write a complete answer sentence with units by echoing the question. So this is brutally important for us, especially in this particular unit, talking about this word units. Units. When I'm talking about units mathematically, what am I talking about? I'm not talking about how we break apart our year in terms of what we're learning in class. When I'm talking about units in terms of word problems, what am I talking about? Oscar.
Feet, square root, like after it says that you have, that you're 6 feet tall, and then like.
So what are the units in what you just said?
Feet.
Feet. So he's giving me an example. Feet, yards, inches. Those are all units that measure distance. We think about liters, cups, teaspoons. Those are all units that measure volume. We talk about feet squared, millimeters squared. Those are all units that measure area. Okay? So when we're talking about units, we're talking about basically what describes how we're measuring or counting something. So units can be even more basic. If I'm talking about counting how many of you are in the room, my units would be there are 26 students. Students would be my units. Units are very, very important in this unit. We're going to learn tomorrow exactly how important units are in this unit. Because what we're going to be doing is we're going to be actually taking the types of problems that we're going to be seeing in these rate and ratio problems, and we're going to be learning how to do them without even necessarily understanding the word problem. We're going to be allowing the units to guide the path to us being able to get those problems correct. Okay? Mr. Ross.
So basically, when you're saying units, it's the subject, not actually the number.
Correct. It's what we use to describe that particular number. How did we measure that number, or how did we count that number? What is it? All right. So when we're looking at this problem, Patrick is 12 years old. His sister Kalia is 5'6", as old as Patrick. Daria is 4 1/3 years older than Kalia. How old is Kalia? When we're looking at this problem, one of the first things that we are going to do is what? Andrea. Box in the question. So this tells me that what Andrea wants to do first is focus in on the question. So part of focusing in on the question from now on, Bijan, is going to be to write this complete answer sentence to the question. Now, we don't know what the number is that's going to be the answer to this question, but we can still answer this question by echoing the question and putting a blank where the number should go. All right? So, how could I answer this question? How can I echo this question, flip this question, mirror this question, and write a complete answer sentence? Brene. How can I answer this question with a complete sentence? Putting a blank where the number that we don't know what is goes. Perfect. Kalia is blank years old. What are my units on this blank? Every blank must have units. What are the units on this blank? William? Years. So this is where we're going to put down our definition of units. This is our unit, or units. And our definition for units is how, sorry, I don't like how. I like describes, sorry, how a number is measured or counted. Units are very, very, very important, especially when we're talking about real-world situations and real-world problems, because Herbie may say, hey, Mr. Boots, how far is it to the gas station? And I could say 10.
10.
Right, and that's the right question. 10 what? I mean, it could be, 10 feet. And she'd be like, all right, I got plenty of gas to make it 10 feet. It could be 10 blocks. She may have enough gas to make it 10 blocks. Or I could say 10 miles. May not have enough gas to make it 10 miles. He doesn't really know. So that's part of the reason why units are so important, is because without a description of how something is measured, it's not really meaningful. Okay? That's part of the reason why it's important, and those measurements are also going to be helpful in terms of doing math. All right? So, sorry, that's only the first part of this. So we said that we focused on the question. This is the main part of our aim for today, but I do want to go ahead and review the other pieces of what we did yesterday by finishing marking up this problem. What other things would I need to do to finish marking up this problem after I have bracketed in the question? Isaiah. Okay, so we need to find the important details, the important information that's given to us. What are the important keywords or the important values here, Mr. Posey?
12, 5 over 6, 4 over 3, 4 and 1/3.
So this is why I believe it is important to reread the problem after having focused in on the question. So I want to know how old Kalia is. So as I reread this, I see Patrick is 12 years old. Okay, I know how old Patrick is. That may or may not be useful. His sister Kalia is 5'6" as old as Patrick. Okay, so if I have a relationship between Kalia's age and Patrick's age, then I would need Patrick's age. So this information is all good because if I have Patrick's age and I have a relationship with Kalia's age, I can find Kalia's age. But that means this relationship between Daria's age and Kalia's age is not helpful. I can say that Andrea is 16 years younger than Mr. Boots, but if you have no idea how old Mr. Boots is, does that matter? It doesn't helpful. It's not helpful. If you don't know how old I am, you can't calculate her age based on the relationship that I just gave you. But if I tell you on top of that Andrea is 1 year older than Andrew, and Andrew is 12 years old, can we find Andrea's age? Yes. So thinking about, that's basically what this problem is. It's giving you two relationships for Kalia's age, but only one of them where you have the other piece of information that you need. So, what information in this particular problem is not useful? What information in this problem is a distractor? Ricardo. Daria.
4 1/3 years older than Celia.
Okay. So that is a distracting piece of information because in this case we don't have enough information to use that. Had we been told Daria's age instead of Patrick's age, that would have been a useful piece of information. All right. Were there any keywords in here that help describe what's going on here? This one's kind of tough because in this case it's really a key phrase. and it's having this 5/6 as old as. So really the number is kind of part of this key word. When we're talking about something being a fraction of something else, that should suggest something to us. So for me, I'm underlining this phrase 5/6 as old as. Basically, anytime we see that phrase as much as with a fraction, that's going to be telling us something. All right? So, Mr. Posey is excited to tell you that Kalia is 10 years old. And when we're talking about type of problem, we don't have a bank of like types of problems that we know at this point. And I'm not going to worry about us writing down the type of problem. As we run into different types of problems, once we start our actual work this unit, then we'll start having types of problems. But I just wanted that to be on the paper so you were going to be aware that's going to be part of your work once we get this unit started. All right? So let's move on to the next problem. Joseph, will you please read this problem for me because I'm tired of talking.
In 1.5 ounce of Colby cheese, 36 of the 60 calories are from fat. What percent of the calories are from fat?
All right, so what do we need to do as we approach this problem? What's the first thing that we ought to do as we approach this problem? Damien, box the question. What percent of the calories are from fat? Now, we now know that when we box that question, the next thing that we want to do is answer that question. Even if we don't have a value to put in the blank, we want to go ahead and answer that question. And we do so by mirroring the question, making sure that we have units on our blank. Hervey. Okay, she says blank percent of the calories are from fat. What are the units that she has put on our blank here? Mr. Ross? Nope. Jacqueline? Calories is way over here, so we're close. Nafisa? Percent. So percent is interesting. I noticed when I said, what are the units, I put little quotation marks around that in my... And that's because they aren't really a unit. Percent is really not a unit. Percent is kind of telling you that your unit here is really just a relationship between two things that are the same. So percent's kind of interesting. We're going to call that a unit. But when you get into higher math, when you get into physics, when you get into things like that, they're going to tell you that percent is not a unit. They're going to tell you it's a scalar and that it is unitless. But we're going to call that a unit for now as we continue to look at our work. All right. So as we look at this, we have now focused in on the question. We have done that particular piece of information. What else do we need to do to finish marking up this particular problem? Genesis.
Circle the important values, which is 0.5, 36, and 50.
Okay, so Genesis is asking us to circle the important values. For me, I like to think through the key words first because sometimes the key words will tell me more about what I'm doing, which can lead me to knowing what the important values are. Because I think that one of these values that you circled right now is actually not important. So what are the key? What are the key words in this particular problem? Winta, what do you think? We're looking for something that's going to tell us mathematically what we need to be doing here. What do you think, gang? Of? I think of the maybe could be possibly considered kind of a key phrase. Really, I think the key word here is percent. Because percent tells me that when I'm talking about a percent, I need a part of a whole. So, actually, here it's very clear when we're talking about percent and we're giving a percent answer, we need a part of a whole. Well, we have three numbers here, so one of them can be a part, one of them can be a whole, and the other is going to be unnecessary. So what's the part, what's the whole, and what's unnecessary, Mr. Matlock?
So the part. Okay, so I think the part is the Kobe cheese.
What value is the part?
Oh, the value. What value is the part? I would say the 5.5 or no 36 of.
36 is part of how many? What's the whole?
50.
Of 50. That's it. So what that tells us is that this 0.5 ounces is not important. Okay? And part of what might have directed us in that particular direction, if we look back at our question or our answer statement that we wrote, it says blank percent of the calories are from fat. So we're looking at percentage of calories. Okay, so if we're looking at percentage of calories, our part and our whole probably should be parts and wholes calories. So ounces wouldn't really play into that for us. All right? Let's move on to the next one. A newsstand in the mall allows people to record their own CDs. Musicians are charged $20 for each CD they record, plus $5 for each hour they use the studio. Wayne records 4 CDs and it takes him 3 hours. How much will it cost? And in parentheses here it says T equals 20C plus 5H, where T is equal to total cost, C is equal to the number of CDs, and H is equal to hours. What shall we do first? Come Yep. Bracket my question, and now we need to answer said question with units. Elmer, how would you answer this question with units?
Chicken equals monkey. Go.
How would you answer that? If I told you the answer was 12, what would you say was a complete sentence answer to this question?
The answer is
12 CD.
$12.
$12.
What? No, he told me about the answer sentence.
How would you write a complete answer sentence to answer how much will it cost if I told you the answer was 12?
The answer sentence. You know what you've been doing down there? Do it right there. The answer sentence. Just look.
Andrea, what would you write? It will cost $12. So in this case, we actually don't know the answer is 12. So we'll write it will cost blank dollars. What are our units for this particular blank? Kevin. Money is not a unit because money can be measured many different ways. Money is measured in the United States in what?
On the bottom?
In the United States, how do we measure money, Purvi? Dollars. In Europe, how do they measure unit? How do they measure money in Europe? William. In Mexico, how do they measure money? Oscar.
Pesos.
And so let's go ahead and finish up this. What would we need to do to finish marking up this problem? For me, I'm going to go to key pieces of information to underline. Andrea, what do you think?
Circle the important values. Yeah.
Okay, what's the important values? So again, this is why I focus on my key details and my key information to underline first. Is because honestly, at this point, I'm not really sure. There are a lot of numbers here. I'm not really sure what's truly important for me to know and for me to use. So what key information do you think we should underline, Hervey? I mean, I could. That would suggest that there's a multiplication going on here. But if I work smart on this particular problem, I'm going to find something else that's way more important than those words. And I'm going to give you a hint. Many of you are stuck on the idea of key words. I'm going to tell you you should maybe stick to something more along the lines of key pieces of information. Bijan would be a key word. I'm going to suggest you should not give me a key word and perhaps find something that would be more along the lines of a key piece of information. Mia.
4 CDs into the hours.
Those would be important values. I'm looking for a key piece of information that tells me mathematically what I need to do. Hervey, what do you think? Those would be some words. We should shy away from key words. And please tell me some key pieces of information or a key piece of information that would tell us mathematically what we should be doing here. William, what do you think?
In the bottom, in parentheses, where it says how to solve it.
Absolutely. So in the bottom, it tells us exactly mathematically what we need to do. It has taken the words and converted it into a piece of math for us already. So if we're working smart, we know that in order to find the total cost, all we need is this equation. So I'm underlining this equation. T equals 20C plus 5H. And in order to solve that equation for the T, total cost, what other two important values do I need? Oscar.
The CDs.
I need to know the number of CDs. So here I want to reread the problem. And where do I see the number of CDs? ECs. Yeah, 4 CDs. So that's an important value. What other important value am I going to need if I'm going to solve this equation for total cost? Renee? 3 hours. And if that's all I need to find the total cost was what I've underlined here, and these 2 things that I've circled, what does that tell me about the first 2 sentences of this word problem? Yang? It's useless, which means they are just a big distraction. How many of you got distracted by these 2 sentences? All of you did, because all of you were like, oh, we need to underline those particular blah, 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 blah. That's why it's important to read the entire question. This is really common anytime that you have something put in parentheses or hints or notes or anything like that at the ends of problems. Those are generally going to be key pieces of information that you're going to want to underline. All right?